In the last unit, we learned that parallel lines are lines that never intersect, and that you can tell by looking at an equation that parallel lines are parallel because they have the same slope and different y-intercepts. Perpendicular lines are lines that intersect at a 90-degree angle. And if you want to be able to tell that from an equation, you again look at their slopes. The slopes of perpendicular lines are opposite reciprocals. So for example, if one of those values is A over B, then the other value is the opposite of B over A. And that would be the slope for the perpendicular line. Now this symbol looks kind of like an upside down capital T. That's a symbol for perpendicular. Another way to say that slopes are opposite reciprocals would be to say that they have a product of -1. So let's start with some quick practice of opposite reciprocal. If I had a slope of 1/2, then the perpendicular line would have a slope of -2 over 1, which equals -2. So opposite means if the first one was positive, then the new one is negative, and reciprocal, that's like where you flip the fraction. So 1 over 2 becomes 2 over 1. The numerator and the denominator swap places. If I had a slope of 3, then the perpendicular slope would be -1/3. Again, it goes from positive to negative, and then it's a little hard to see where you would flip this fraction because 3 doesn't look like a fraction. But remember, you could write 3 as 3 over 1, and then it's a little bit easier to see how when you flip it, it would become 1 over 3. Same idea with -2. That's not a fraction, so you would think of it as -2 over 1. The opposite reciprocal, so the slope of the perpendicular line, originally it was negative, so now our new one's positive. And if we take the 2 and the 1 and we flip them, we get positive 1/2. If we have a line that has a slope of -3/4, the perpendicular slope would be positive 4/3. So it went from being negative to being positive, and the fraction flipped. The 3 and the 4 that were in the numerator and the denominator, they switched positions. So if I want to write the equation of a line perpendicular to some given line through some given point, I'm going to be using point-slope form again. Again, they're giving me a point, and my point is the x1 and the y1. And it doesn't quite look like they're giving me a slope right away, but because they said that our line would be perpendicular to the line y equals -3x plus 2, and we know that perpendicular lines have opposite reciprocal slopes, they really are kind of giving me a slope. So the line that they gave me, if I compare that to y equals mx plus b, that has a slope of -3, which means my perpendicular line has a slope that is the opposite reciprocal of -3. Opposite means it would be positive. Reciprocal, remember -3 doesn't look like a fraction, so we're going to think of it as -3 over 1. So then the reciprocal would be 1 over 3. So our perpendicular slope would be positive 1/3. So now we've got a point and a slope. We're going to use the point-slope equation. Y minus y1 equals m times the quantity x minus x1. Remember that the x and the y remain x's and y's, but the other 3 values get replaced with numbers. So our x1 was a 0, our y1 was a 4, and we just figured out by using opposite reciprocals that our slope would be positive 1/3. So this would be our answer in point-slope form, but then to change it to slope-intercept, I would simplify this. Now, remember our identity property, if you add or subtract 0 to anything, it stays the same. So x minus 0 is just x, and then 1/3 times x is 1/3 x. And then to isolate the variable, I would use inverse operations. 1/3 x plus 4, those are not like terms, so I can't combine them in any way. I would just get 1/3 x plus 4. So then my final answer in slope-intercept form is y equals 1/3 x plus 4.